Lesson 6.2, Kites and Trapezoids. Manuel draws a diagram of a kite, and here's the visual of the kite, with QS as the line of symmetry, and it's for a key fob. He makes a list of conclusions, which are right here. You have to determine if you agree or disagree with these conclusions that he made. And then later in part B, it says, what other conclusions might you make in addition to what Manuel made? So try to think of other things that you might discover of this kite drawing. Investigation. It says, how are the diagonals of a kite related? So when you look at this kite and when you visualize it, I want to show you the solution. So there's different things in a kite, which we're going to break them down. First of all, congruent sides. So if you see these tick marks, AD is the same as CD. So these two sides are the same. The longer two sides are congruent, and then the shorter two sides are congruent, which the diagonals that are created from there will create perpendicular or 90-degree angles when they intersect, which means since they are 90 degrees, and this point D is equidistant from A and equidistant from C. That means this dashed line is the perpendicular bisector of AC. Now, AC going up and down, like visually up and down, this is not bisecting BD. In fact, it says exactly one diagonal will bisect. So only one of these is bisected, and it's the shorter of the two sides, the two diagonals. So this shorter diagonal is the one that's bisected. The longer one is intersected at a 90 degree, but it's not bisected. That's true for all kites. What is the measure of AXB? When you look at this and you're like, okay, angle AXB, that point X is the point that they're talking about, the angle. So AXB, sorry, it's this way, AXB. That's 90 degrees. This is 90, that's 90, that's 90. They're all 90. It says if AX is 3.8 from here to here, what would the total be? Keep in mind, this is bisected. So if this is 3.8, then this other side would be 3.8. So find the total. Theorem 6.3. This is a theorem that just talks about the rules of diagonals of the kite, and it is literally saying that if it's a kite, then the diagonals will create a perpendicular angle, and the shorter side will be bisected. Okay, there will be a bisected segment. So it's perpendicular bisector of this shorter side, but all four of these angles will be the same. Notice these congruent side lengths, which is true for, again, for all kites. So how are we going to use that to solve problems? So we look at this problem and it says, this is a quadrilateral, quadrilateral meaning that there's four sides, and it's a kite, and it says, what is the measurement of angle 1? Well, right here, I'm hoping you know that instantly. That angle 1 should be 90 degrees. And there's no work to show. You just know the rule. They're 90 degrees. They're intersected at a 90-degree angle. The next part of this question, what is angle 2? Angle 2. This we're going to actually do some calculations a little bit, and I'm going to write these down. So let me get some colors for you. And I can see that this triangle right here is an isosceles triangle because there's a tick mark here and there's a tick mark right there. So that's an isosceles triangle. If you need to draw it, redraw it so it's straight up, that's fine. But you have a 35-degree angle right here, which means you have a 35-degree angle over here for angle 3. So that means you have 35 plus 35 plus this angle 2, which we don't know. So I'm going to say plus, we'll just call it X. So this whole thing X equals 180 because it's a triangle. When you combine like terms and solve, so you have 70 plus X equals 180. Hopefully you can read that. Subtract 70 on both sides. And you're going to be left with X equals 110. But that's not Angle 2. Angle 2, because these two triangles right here would be congruent, and we'll worry about the proof of that later, but because these two triangles are congruent, these two angles, angle 2 and this angle right here, those angles would be congruent. So x, if I cut that in half, that will give me angle 2. And then you can check your answer on there. So go ahead and take x, cut that in half, and you will get angle 2. We had already talked about this, but we found the measure of angle 3. I had already said that if this is an isosceles triangle, which it is, then angle, this 35 would be the same here as angle 3. And you don't have to show any work. You could even just write base angles of an isosceles triangle theorem if you want to record why you know that answer or how you know that answer. Okay, here's another quadrilateral, and they're kites. What is the measurement of angle 1? This is a little bit similar to what we just did, but if I have this angle 1, I know this is 90, so I'm going to say, I'll just say angle 1. The measurement of angle 1 plus that 90 plus the 32 should equal 180. These are still triangles that we're breaking up. The kite is broken up into 4 different triangles, or you could say 2 different triangles if you want the bigger ones. Okay, so find angle 1. Combine like terms, subtract those, and you would get the measure of angle 1 equal to whatever you get. And so I don't want to spoil it for you, so you can figure that out. And then it says find the measure of angle 2. Keep in mind, this triangle and this triangle, these are congruent triangles. What would angle 2 be? Take a second and think that out. Hopefully you can figure it out. For example 3, it actually is kind of extensive, but it's talking about a roof, a trapezoid shape. So we're talking trapezoids now, not a kite. And it goes through proving why this or how it could be symmetric. So I'm going to slide this down. This is a great proof to look at, and these are the altitudes. The heights would be the same. So if the heights are the same and these diagonals right here, they're not diagonals, these side lengths right here are congruent, these two triangles would be congruent because of HL. And then it keeps going. So if you have second, look through this and it talks about how they are or are not symmetric based on congruent triangles. So look at that. Given the isosceles trapezoid is a trapezoid where it has congruent sides, not the bases. You know these are the bases because these are parallel. So the bases aren't the same, but these other sides, those are the same. This is congruent. It's supposed to be a dash. Okay, and so it says find all the angles. Well, if you have an isosceles triangle, this corner angle and this corner angle will be the same. So the angle Q is 135. I need to find angle P and angle S as well, which they would be the same. So I'm going to call this X and this X. From our last lesson, we should know that 4-sided figures have a total of 180 and minus 2 degrees, interior angle degrees. So 180, there's 4 sides minus the 2. That should equal 135 plus 135 plus those 2 x's, plus 2x, just that x and that x. And when I do this, 180 times 2, and again, this is the interior angles of a 4-sided polygon, I get 360. So I know that these have to total 360. So you have, go ahead and combine these like terms. That's not a negative, that's just an extension of the addition sign. And try to solve for x. And when you get x, that will find these 2 base angles. Given that ST and RU are parallel, so we're going to write those parallel sides are definitely the bases. So I'm going to create little arrowheads here so I know that those are parallel. What is the measure of TUR? This angle right here, okay, which would be the same as this angle right here. Think of a linear pair. 47 plus the angle that we're looking for, x, should equal 180. Because this 47 right here and this angle that I marked in blue, those make a straight line. So figure out what x is, whatever you get, angle U is the same. Theorem 6-4. In an isosceles trapezoid, each pair of base angles is congruent. I just talked about that, but here's the rule that shows it. And you can actually manipulate this if you want. So as long as those two sides, not the bases, but the two sides are the same, the base angle pairs will be the same. So this pair down here, base angles, and this pair up there, also called base angles, those will be congruent to each other. Not all congruent, but just the pairs will be congruent. Another theorem, the diagonals of an isosceles trapezoid will be congruent. This only works if the trapezoid is isosceles. Then this whole segment, this diagonal, and this whole diagonal will be congruent. And we're going to go over some problems that use that information. So we're going to do that now. All horizontal beams of a high voltage transmission tower are parallel. So all these parallel, parallel, parallel. They're all parallel. And if angle 1 is 138, so right there is 138, what is the measurement of angle 2? If it were me, I would simplify this drawing a lot. So basically just make a trapezoid. And since this is 10 feet, this is also 10 feet, these two sides right there. So angle 1 is 138, and I'm going to write it right above it, which means this angle over here is 138. That's an 8. Okay, so I've got 138 plus 138 plus this angle 2. But there's two of them, so I'll just call this x and this x. So x plus x. And I'm hoping you remember that a 4-sided polygon has to equal 360. If you didn't remember that it's 360, I'm going to squeeze this in right here. I'd say 180 times n minus 2, where you plug in the 4 because it's a 4-sided figure. So 180 times 4 minus 2, and that's how I got that 360. Okay. Once you calculate this out and figure out combine like terms, and I'm hoping that you can solve for x by yourself. The second part, part B, one cross support of the center of the tower measures 4c plus 3, and this is the other measure. What is the length of each support? So we should know this is a trapezoid, an isosceles trapezoid, so those diagonals should be congruent. So I'm going to write 4c plus 3 needs to equal, because they should be congruent if that's an isosceles trapezoid, 6c minus 5. Let's get those c's together. So I'm going to subtract 4c on both sides. So I would have 3 equals 2c minus 5. And I'm hoping you can see where I'm going with this. Get c by itself, add 5 to both sides. 8 equals 2c. Divide by 2 on both sides, and you should have that x equals 4. Now, I want to double check that that's even what it's asking because I can't remember the question. So I'm going to go back here. What is the length of each cross support? Nope, that's not what it's asking. I'm going to take this x and plug it in to either 4c plus 3. Oh, and that's a c. I changed my c's to an x's, sorry. I'm going to change this c. I think it's just out of habit. So I'm going to say 4c plus 3, and I'm going to take that 4 plus 3 and calculate to figure out what the length is. If it were me and this was a test or a quiz, I would also plug it back into here, the 6c minus 5, plug in that 4, and see if you get the same answer, because if you don't, you know you did something wrong. So these two should be the same value once you solve for them. This next theorem is the trapezoid mid-segment theorem. So long time ago, when we learned about midpoint, you had 2 points on a graph, and to find where the midpoint of those 2 points were, you actually found the average of the coordinates to find the midpoint. It is very similar to the mid-segment. So I know it's a mid-segment if each of the sides is bisected. So these are 2 congruent. These 2 are congruent. So I know this BA has been bisected. CD has been bisected, which creates midpoints. So X is a midpoint, Y is a midpoint. When they're together, or put together with a segment, it's called a mid-segment. So let's look at this mid-segment as I manipulate this. As I manipulate the measurements, I can tell that no matter what happens, that mid-segment's going to change based on the length of each of the bases, top base or bottom base. Okay? And there's a theorem or a rule for that, and it's right over here. The mid-segment will equal half of the two bases. So when I write this out, I usually write it like this. The mid-segment equals 1/2 base 1 plus base 2. So it's literally taking the average of the two bases. Let's try some problems. This is the application example 5. Paxton makes trapezoidal handbags for her friends. She stitches decorative trim along the top, the middle, and the bottom. So these dashed lines are what we're talking about. How much trim does she need for 3 handbags? Well, first of all, you have 3 different lines. You would have the front and the back, and you would have this times 3 because we need 3 handbags. So this goes through step by step, the solution, but I'm just going to write a few things. You can look at the solution in the interactive textbook. I'm going to have us write down mid-segment, or just M, equals 1/2 the 6, base 1, plus the 9, which is base 2. Okay, so you take the average of the two bases. So that mid-segment equals 1/2, 15. And 1/2 of 15 isn't a pretty number, but it's doable. So my mid-segment would be 7.5. So if this length right here is 7.5, and I have a 6-inch, and I have a 9-inch, you need to figure out the total of those. So I've got the mid-segment. I'm just going to circle it so it's kind of out of the way. And then I have the 6-inch plus the 7.5 plus the 9 would equal 1 bag, 1 front of 1 bag. And I have to take all of that times 2 because there's the front and the back. This amount would give 1 bag. Because front and back, that's the times 2, and adding each of the lengths of the decorative ribbon. And once you get that answer, multiply by 3. See if you can get it. I really like problems like this. I'm going to make this length X because we don't have the base. And I'm going to remember that my mid-segment equals 1/2 the base 1 plus the second base, base 2. And I'm just going to plug in everything I have. I'll call this 4/5 XY, my base 1. But 4/5 of XY, let's figure that out first. So I'm going to go over here just to get some work out of the way. 4/5, well, of XY. XY is 25. So I need to figure out what's 4/5 of 25. And if it makes it a little bit easier for you, you can have the fractions because 4 times 25 is 100. And then the denominator is 5 times 1 is 5. So 100 divided by 5, you should get 20. So instead of saying 4/5 XY, I'm going to say 1/2 20 plus my X should equal my mid-segment, 25. And distribute that 1/2 or solve it a different way, but try to solve for X. Once you get X, you will answer the question, the measurement of KL. Concept summaries, the basic things in this whole lesson, kites and trapezoid. So for kites, you need to know that it is symmetric with that long side. It's symmetrical. AB is the same as AD, and this shorter segment is bisected by the other diagonal. With a quadrilateral, that's a trapezoid, isosceles trapezoids, the diagonals are congruent and these side lengths are congruent. And if you're looking for the mid-segment, then you take the average of the two bases. I hope that helps.